Okay, so in this section, we're going to describe quantitative data using certain numbers. So for example, if I have the student's grade here in this dot plot, then I'm interested to know where the average for this class is, and depending on the shape of the dot plot, I will be interested in not only the mean or average, but also where the median is. And I think we talked a little bit during class about this. If the population is skewed, then the median is something that I would really want to know, because it tells me, okay, 50% of the class is below this grade and 50% of the class is below that grade. So in here, the median, I'm just going to approximate it, maybe 78, where I see that visually half of the class is above that value and half of the class is below that value. And the mean is not going to give me such a number. The mean is just going to give me the average. Let's say that everyone got the same grade. Let's see what the equivalent is. So one important measure of center, as I said, is the mean. And I'm going to explain this slide. And this is just not to confuse you, because it can be a little overwhelming, these new symbols. So instead of using X, Y, Z, and the letters of the alphabet for variables, I'm just going to use only one, and I'm going to say, okay, X represents student's age. So if this is data that I'm going to use across classes, then definitely Mrs. Bustillos has a class of 24 students. So I am going to be measuring 24 piece of data, and then let's say Mr. Larson next door, it has 16 students, so he is going to be measuring 16 observations. So if X is the student's age, then what I'm going to do is I'm going to measure X sub 1, which would be the age of somebody in my class, X sub 2, which will be the age of somebody else in my class, and so on. And then I'm going to have all the way to X sub 24, which is just the 24th observation, the 24th person in my room, you know, with age whatever. So in the same idea, Mr. Larson would have X sub 1, X sub 2, X sub 3, X sub 4, and so on up to X sub 16. Since we're going to be talking about in general terms, I don't know how many students, or I don't know how many observations I'm going to be having. So let's say that we're just going to have X sub n we're going to have n observations, so I'm going to be using X sub n variables per se. So to find the mean, for example, what am I going to do with all those ages? Well, I don't know, 16, 17, 16, 18, and so on. What am I going to be doing with those ages? I'm just going to add them up and then divide by the number of numbers. So I'm going to add all the X sub 1 plus X sub 2 and so on, and I can use ellipses here to just say, okay, you know, let's continue all the way to X sub 24, and then I'm going to divide by 24, and that will be my mean. Now the mean is going to be represented by the symbol X bar, and that's how it's read, and that's what you can see here. This is the mean, and this is the symbol, and this is the way we pronounce it. And this is how we find it. We add all the observations and we divide by the number of observations. Since this is a general formula, you're not going to be adding 24 or 16, you're going to be adding n number of observations. So that's why it says up to X sub n. Now, instead of writing it this way out, sometimes you may see it written in this shorter way. Now, this is the Greek letter sigma, but it's read as sum. So all it says is I'm going to add, or I'm going to find the sum of all the X sub I that I have. Now in here, I'm not going to go into detail why it is I rather than n, but this is just to say I is going to be 1 and 2 and 3 and 4 and 5 and 6 all the way to n. N is a fixed number if you're talking about a particular situation. But I is the number that is going to be changing. First observation, second observation, third observation, and so on. So this is just a very complicated but very short way to find the mean. Now the median, please remember the middle child. So it's not about the number in the middle, but it's about the number in the middle when we have data that is in order. Now this is something that came up last class. If the number of observation is odd, if I have an odd number of numbers, 6, 10, 11, 13, 15, so I have 5 observations, which is odd, so the median is, once you order the number in the middle. But if you have a set of even numbers like 6, 10, 11, 13, 15, and 20, then I have 1, 2, 3, 4, 5, 6. 6 is an even number. Then the number in the middle would be the average of these two numbers that are in the center. So that's why it says 2 center observations. So the average of 11, 13 is 12. So that would be the median. And the median is not an observation here. It's just the number in the middle. I know that half of my observations are above 12, and I know half of my observations are below 12. So if you have data, you can organize it and find the number in the middle, which is the median, and you can add them up to find the mean. However, if this was not given, if a stem plot was given, then that's easy to find because you can retrieve all the data observations from this graph. I know that I have an observation that measures 5, which is the number of minutes that a New Yorker commutes. So 5 minutes, 10 minutes, 10 minutes, 15, 15, 15, 15, 20, 20, 20, 25, and so on. So I can retrieve all those numbers here to find the mean. And to find the median, since I know that I have 20 observations, I know the median is going to be between the 10th and the 11th observation. So I just count in order. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So I know that the median is going to be between 20 and 25. And the average of those numbers is 22.5 minutes. So I know that out of that sample of 20 New Yorkers, half of them commute more than 22.5 minutes, and the other half commute in less time than that. The mean and median are very useful numbers to describe our population. If I tell you that the mean of the grades in my AP statistics class is 98, then you are going to think, oh, well, this is a very good class. And the same with the median. If I tell you that the median in my class is 90%, then you're going to think, oh, okay, this is a very high-performing class. However, they do give you a slightly different information. If I give you the median is 90, so that means that half of my class score above 90 and half of my class score below 90, which is different from the average. The average just says, okay, if everyone had the same grade in the Sustillo's class, they will be having whatever grade the average is. The average is making everyone equal. So when are we going to pick the mean or the median for center when we describe data? Well, if it's a symmetric distribution, if you see the dot plot that makes this kind of a shape, then this is definitely symmetric. Or if it's even like this, it is definitely symmetric. So you would pick the mean because it's meaningful. And also, by the way, the mean and the median will be very close if you're talking about a symmetric distribution. But if you see that we have, I'm going to move over here. If you see that we have outliers and the distribution looks skewed, then the median, the mean is going to go more to the tail. The median will be more meaningful because the median tells you, oh, okay, half of the observations go this way and half the other way. The mean probably not so much. So that's the rule that we're going to use. Now it just says don't confuse the word average with typical. These two are not going to be synonyms in this class. Average is the other word for mean, and typical, we're going to save it for the median. Now, when we measure a spread, the only thing that we have seen so far is range, which is the highest observation minus the lowest observation, just to tell us where the observations are varying. But another way to measure a spread is by finding the interquartile range. Now all it means is I want to know how much two important numbers for my distribution are spaced. The two important numbers that I'm talking about are called the first quartile and the third quartile. So going back to the 20 New Yorkers that were questioned to how long they commute in New York City, I want to know, so I have 20, let me see, I have 20, so 20 people, so I'm going to divide it in groups of 4, okay, so I want to know the lowest 25%, and I want to know the highest 25%. So in each circle I'm going to have definitely, oh, 1, 2, 3, 4, 5, I did one more. In every group I'm going to have 5 people, and not only that, but I know that the top 25 is going to have the highest commuting time, the lower 25 is going to have the lowest commuting time, and that these two are going to have the middle time. So let's just look at the example so that I can clarify it better. So we found the median, which is 50. It divides the population into 50 and 50. So I know half of these New Yorkers do more than this time and half less. The first quartile is going to be the median of the lower half. You can look at it this way. So I have 10 observations. That's an even number. The two middle is 15, so the average is 15. So the first quartile is 15, which means in average, half of the half was above 15 and half of the half was below 15. Now I'm going to do the same with the top 50%. I know that these 20 New Yorkers have this commuting time, and I'm just going to find the median of these numbers. So the median of these will be the average of these two, which is this one. So I'm going to call this the third quartile. So now the space between third quartile and first quartile is going to be my interquartile range. That's why it's called inter, because it's between quartiles. So not only that you know half of those New Yorkers commute for more than 22.5 minutes, you also know that a quarter of them, or 25%, commute more than 42.5 minutes. And you also know that a quarter of them commute less than 15 minutes. Or you can see it as, I know that 75% commute more or longer than 15 minutes. So that's a different way of looking at quartiles. But anyhow, the interquartile range is 27.5 minutes. So you see how if you were to ask a new New Yorker, how long does it take you to commute, then if the answer is going to be, is going to vary for almost half hour. You know, they could tell you anywhere from 5 minutes to 35 minutes. So that's the kind of information the interquartile range gives you. Now, I also told you that there will be a formula, because I know how much you love formulas, about how to identify outliers. We only saw potential outliers because we saw how the dot was very separate from the other dots, and then that was intuition, but now we're going to have a rule, and is the 1.5 times the interquartile range rule for outliers. So which means if I know the interquartile range right here, right, it's the difference between the third quartile and the first quartile. If I know that there is 27.5 minutes in between, I just multiply this number by 1.5, and I'm going to get 41.25. So the only thing that I do is, if there is a number that is too high compared to the rest of the numbers, I'm just going to say, okay, third quartile, I'm going to add this 1.5 times the interquartile range, and I'm going to see if that number that is far away is farther than that. So when I add the third quartile and 1.5 times the IQR, I'm going to see that 85 is way more than that, because when I add these two, it only gives me 83.75 minutes. And this observation says 85 minutes, so that's past that. So this is a confirmed outlier. Not only that I think that it's too far away from the other dots, but it's definitely far. It's farther than 1.5 IQR. And I will have to do the same on the other side. Sometimes observations are very far away from the rest of the data on the other direction. So the first quartile is 15. Now I'm going to take away, because I'm on the left side, take away the 41.25, which is 1.5 times the interquartile range. And then I'm going to see if there are some other observations below this number. Now this number is negative, and I know if I'm measuring time, I'm not going to have any negative observations. So there is no outliers here on this side. And that's all it means. Now the 5-number summary are the numbers that we're going to use from the data to be able to either draw a box and whisker plots, or just know more about the distribution of this data. So I'm just going to show you in the calculator very quickly how to do that. In here, the only thing I need before I start is make sure that your y equals is empty. Make sure that when you go to mode, and if you scroll down, the stat diagnostics is highlighted on. I want them on. So that's it. You just start. So you press stat and then enter, because you are going to edit a list. Now I already entered all the numbers that I want from this exercise, the 20 commuting New Yorkers. So I enter 20 observations. Okay, the last one was 45, and I enter them in this order because it really doesn't matter. I don't have to order it for the calculator. So how do I get the 5-number summary? I'm going to go back to stats, and then I'm going to move over to calculations. So these are statistical calculations. Since I only have one variable, which is just time, so that's what I'm going to pick right now. So I pick enter, and I'm going to press enter again, and then it's going to give me a lot of information. It's going to tell me how much the mean is. It's going to tell me, remember that summation symbol, the sigma, the Greek letter sigma. So this is the summation of all the x's. So it's 625 minutes overall total. Now it's giving me what we're going to know as the variance, and it's going to give me the standard deviation, which is something that I'm going to talk about in a few minutes. And it gives you the n, which is the number of observations, 20. If you scroll down, it's going to start giving you the 5-number summary. The minimum value is 5. The first quartile is 15. The median is 22.5, which we already calculated. The third quartile is 42.5 minutes, and the maximum observation was 85. So with those numbers, we're ready to graph a box plot. So the idea is just to pull one axis, and I know this is minutes, commuting minutes, okay? And then I just have to make sure that I make tally marks that are equally spaced. So I know I'm going to have 0, 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60. And I think it's not going to fit in my little camera. So 30, 40, 50, 60, 65, 70, 75, 80. Do I need that much? I don't know. What was, 85 was the maximum, so I know I'm going to need that much. See, so it's always useful to just keep an eye on what you're doing. Okay, so since we didn't have an outlier, I know that the lowest observation, which is 5, is going to have a tick mark. Now the first quartile is 15, so I make another tick mark here. The median was 22.5, and I'm going to have another tick mark here. And I know the third quartile was 42.5, which is, I think over here. I can't see the numbers again. Entry. Okay, 42.5, yeah. Now, with the median and the first and the third quartile, I'm going to make the box. With the lowest observation, that's going to be one of the whiskers. Now, the outlier was 85. and that's something that we determine by doing 1.5 times IQR. The calculator is not going to give you the outlier, you have to calculate it yourself. So that's the outlier. Now the previous observation before 85, I think it was, let me go back to the table, 65. So 65 is going to be my tally mark, and that's going to be the end of the whisker from this way. So now I know that the median is here. Notice how spread out this quarter of the population is and how crunched up here this quarter of the population is. We're going to see the meaning of that later on. And that's how I draw a box plot. Now, if you want the calculator to do that for you, you can also have the box plot drawn. If you go to stat plot and go into plot 1, turn it on first, and if it's not on, put the cursor there and just press enter. And there are different types of graphs, that we're gonna be able to do: scatter plots, line graphs. I have histograms, I have box plot and whiskers with outliers, without outliers, and I think this is a cumulative graph. So I'm gonna pick that one, the one with the little dots. Now you have to tell the calculator, I'm gonna use the data that I put in list 1. And that's all. So now you graph. You may see something different depending on what zoom you used. So I'm gonna recommend that if you don't see the picture, do zoom and then scroll all the way down to zoom stat. And that will give you a very nice way of looking at your graph. You may not even see it depending on where you are in your calculator. So that's it. That's pretty much what we have drawn here. It just looks a little fatter, but I like it. Well, anyway, it doesn't matter. So if you would like to practice constructing a box plot, you can use this slide to do so. Now, measuring the spread, besides finding the range or the interval,